Let's quickly go through the four fundamental laws of thermodynamics. These four laws provide the foundation for understanding all thermodynamic processes. The first one is the zeroth law. Zeroth law of thermodynamics defines thermal equilibrium and temperature. It states that if two systems are each in thermal equilibrium with a third system, they are also in thermal equilibrium with each other. Suppose A, B, and C are three thermodynamic systems. A and C are in thermal equilibrium. B and C are also in thermal equilibrium. Then zeroth law states that A and B will also be in thermal equilibrium. Next is the first law. First law of thermodynamics is a restatement of the law of conservation of energy. It states that energy cannot be created or destroyed, but it can be transformed from one form to another, such as from heat to work. Mathematically, first law can be represented as Q equal to W plus del U or del U equal to Q minus W, where Q is the heat transferred, W equal to work done, and del U is the change in internal energy. Next, second law of thermodynamics. Second law of thermodynamics has different formulations. I will show only the two major statement. First one is the Clausius statement, which states that heat cannot spontaneously flow from a colder body to a hotter body. The second one is the Kelvin-Planck statement, which states that it's impossible to construct a device that operates in a cycle and produces no effect other than the transfer of heat from a single temperature reservoir and the performance of an equivalent amount of work. Mathematically, the second law of thermodynamics can be represented as circular integration delta Q by T is greater or equal to 0. The term in the left hand side is actually ds, that is ds is greater or equal to 0. Next is the third law of thermodynamics. The third law of thermodynamics provides an absolute reference point for entropy. It states that the entropy of a perfectly crystalline substance is exactly 0 at absolute 0 temperature. Mathematically, third law of thermodynamics can be represented as limit t tends to 0, S equal to 0. That's all for this short video. Thank you. Thank you all for watching my videos.